Question number 24. Evaluate whole integration from pi by 4 to 0 sin x plus cos x upon 16 plus 9 sin 2x dx, or evaluate whole integration of x square plus 3x plus ex dx from 3 to 1. Solution. Let I be the whole integration of sin x plus cos x upon 16 plus 9 sin 2x dx from pi by 4 to 0. Here we express the denominator in terms of sin x minus cos x, which is integration of numerator. Here sin x minus cos x whole square is equal to sin square x plus cos square x minus 2 sin x cos x, that is equal to 1 minus sin 2x. Now sin 2x is equal to 1 minus sin x minus cos x whole square. Putting the value of sin 2x, we'll get I is equal to whole integration sin x plus cos x upon 16 plus 9 1 minus sin x minus cos x whole square from pi by 4 to 0. Solving it further, we'll get the value as whole integration sin x plus cos x upon 25 minus 9 sin x minus cos x whole square dx from pi by 4 to 0. Now we'll let sin x minus cos x as t. That would make d sin x minus cos x is equal to dt. Now cos x plus sin x dx is equal to dt. Also x is equal to 0, that makes t is equal to sin 0 minus cos 0 is equal to minus 1, and x is equal to pi by 4 as given in the question. That makes t is equal to sin pi by 4 minus cos pi by 4 is equal to 0. Now putting the values in the above equation and integrating it, we'll get integration as I is equal to 1 by 9 into 1 upon 2 into 5 by 3 log 5 by 3 plus t upon 5 by 3 minus t, whole integration from 0 to minus 1. Integration of I is equal to 1 upon 30 log 1 minus log 2 by 3 upon 8 by 3, that is equal to 1 upon 30 log 4, that is equal to 1 upon 15 log 2. Evaluate whole integration of x square plus 3x plus ex dx from 3 to 1. Integration of x square plus 3x plus ex dx is equal to fx integration of fx dx. When fx is equal to x square plus 3x plus ex, that makes a is equal to 1 and b is equal to 3. Now putting the values in the formula, we'll get f a plus rh equal to r square h square plus 5rh plus 4 plus e into erh. Now integrating fx plus fx dx from b to a, limit n to infinity hf a plus rh. Solving the limit further, we'll get this equation as n equal to infinity, hence h will be considered equal to 0. Solving further, we'll get 62 upon 3 plus e raised to the power 3 minus e as our final answer.